Okay, you're going to see that your video notes are going to have two parts to them. For today, for Tuesday, we did the first part. I'm going to come back here and do the second part of our notes, and we're talking about an inscribed polygon. Now, an inscribed polygon is going to have all of its vertices. Whenever they say it's, you've got an inscribed polygon, all these vertices here are going to be right on the circle. Okay, so if this is the case, we say the circle's circumscribed about the polygon, or the polygon is inscribed inside the circle. Okay, and there's a couple of different characteristics when this happens, and a couple of theorems that kind of peel off of this. Okay, and the first one is dealing with the right triangle. Okay, if you have a right triangle, here's your 90 degrees. This is your hypotenuse, right across from the 90-degree mark. And the right triangle is inscribed in the circle, meaning all of its vertices are on the circle. All the angles meet at the circle. Okay, if a right triangle is inscribed in the circle, then the hypotenuse right here is going to be the diameter. Now we know that this is diameter because we look at it going right through the center. But if they gave you a right triangle that was inscribed in a circle, and you didn't have the center here, you would know that if this is a right triangle and all these vertices are on the circle, this automatically would be your diameter. But again, here they show you this going through the center, but if they didn't show you the center, you would know if that was the hypotenuse, it would be your diameter. Okay, that's going to be your diameter, and that also would tell us that this is 180 degrees. Okay, this arc would be 180 degrees. Okay, so it would form a semicircle. Okay, the next theorem we're going to look at is when we have a quadrilateral inscribed in a circle. Okay, if and only if the opposite angles are supplementary. Okay, so what do they mean about this? When we're talking about opposite angles being supplementary. They mean, first off, we talk about opposite angles. The opposite angle to D would be F. Okay, so if they're supplementary, that means that angle D plus angle F have to equal 180 degrees. Okay, and also angle G plus angle E also have to equal 130 degrees. Okay, it's basically what we're talking about when we talk about opposite angles. Okay, all right, let's look at some examples that are basically going to sum up what we've done to this point. Okay, when we're talking about an angle here, they want to find the value of each variable. So basically, you just want to find the value of x. And we're given 2x here. This is an inscribed angle. Okay, remember what we said. 2 times your inscribed angle is going to equal your arc. So you have your angle right here, and that basically hits where it intersects the circle right here, gives you this arc. Okay, so arc AB. So 2 times angle C is going to equal what arc AB is, the measure of arc AB. So 2 times 2x, this is the angle right here, angle C, okay, is going to equal this arc. Well, we know if this is a diameter here, and we know it is because it goes through the center, okay, this arc is going to be 180 degrees, a semicircle. Okay, so 2 times this angle is going to equal the arc, 180 degrees. All right. And then we just do our due diligence for solving this equation. 2 times 2x is going to give us 4x equals 180. Divide by 4, divide by 4, x is going to equal 45 degrees. Okay? X would equal 45 degrees. Get rid of this here. Okay, now we're going to look at basically a problem that's going to be taking information from the last theorem that we looked at, where we said that two angles are supplementary, meaning two opposite angles in a quadrilateral are always going to be supplementary, okay, meaning they're going to add up to 180 degrees. We're talking about two angles with that are in a circle inscribed, and you have a quadrilateral inscribed inside a circle. So the opposite angles are going to be supplementary. So Z plus 80 is going to equal 180 degrees. Okay, so in this case, Z is going to end up equaling 100 degrees. Okay. And like a lot of these problems, they'll ask you for multiple things here. If you look at Y and E, okay, they're going to be opposite angles. They're going to have to equal 180. So Y plus 120 is going to equal 180 minus 120 minus 120. Y is going to equal 60 degrees. Okay, Y will equal 60 degrees. Okay. Okay, we're going to move down to example 4. Okay. Now, example 4, I'm going to do. I'll expose you to this. We might have like one on the worksheet that might be like this. But it's a good problem that kind of gets you thinking. Okay, we're talking about systems of equations. This is something you'll see definitely down the road when you get to trigonometry or pre-calculus. And the big thing here is setting this up. Okay, we know that when we look at two opposite angles for a polygon that's inscribed inside a circle, they're going to equal 180 degrees. So we know that 3y plus 3x equals 180. Okay. Now, our problem here is that we're dealing with two different variables. If they were both x's or both y's, we'd be able to solve this. We wouldn't have any problem at all. But since they're both two different variables, we can't do anything with this. What we need is another equation. Well, we know 3y plus 3x equals 180. We also know that 2y plus 5x also equals 180 degrees. Okay? Now, you can do a couple different things here if you wanted to. Sometimes you use substitution. I probably would use the elimination method. Again, this is a review of something, we talk about in all math. Sometimes you go back and use something you haven't seen in a while. This comes from algebra, okay? This is a system of linear equations. And with the linear equations, okay, we have to find an opposite here. 2y and 3y, they're not opposites. 5x and 3x are not opposites. What we have to do is multiply one of them, or actually in this case, you're going to have to multiply both of them to get an opposite. So what I'm going to do is I'm going to work to try and find my opposite right here. I always like to go with the two lower coefficients. All right, so to get an opposite, I'm going to be able to multiply this 3y by 2. Okay, and that's going to end up giving me a 6y. And I'm going to multiply this 2y here by -3. Okay, I'll take this away. All right, and what that's going to do, if you remember from what you did last year, towards the end of algebra, we had systems of linear equations, is when we multiply this 2 to the 3y, that's going to give us 6y. Okay? When we multiply the -3 to the 2y, that's going to give us -6y. So we have our opposites here. Now when we're talking about opposites, you're talking about the same variable, but coefficients that can cancel each other out, and that allows us to work with something here. But also remember, we didn't just multiply those first terms. When we dealt with systems of linear equations, okay, we multiplied the first terms, we also multiply each term here. Okay, so you're going to have to do 2 times 3x, which is 6x, and then 2 times 180, which is going to give you 360. Okay. And then on the bottom, -3 times 2y gives you -6y. And again, that's what you were going for. You wanted to get your opposite right there. -3 times 5x gives you -15x. And -3 times 180 is going to give you 540. And that's going to be -540. Okay, so that's the equation that you had set up right there. Okay. Now, you're going to end up getting, when you combine everything here, obviously your y's are going to cancel out. And that's what you want it to do. Okay, in a system of linear equations, your goal is to get one variable to cancel out, and your ultimate goal is just to work with one variable. Get that answer, put it back in here, and solve for your other variable. Okay, so we're going to get, and we have 6x minus 15x, we're going to get -9x. And when we have 360 minus 540, it's going to give us -180. Okay, we have our 9 go into 180, we just solve this equation, or -9, I'm sorry, -9. So we're going to get x is going to equal 20. Okay, so we got a value for x. X is going to equal 20. Now all we can do right here is you can pick either one of these original equations. Okay, I'll pick the top. 3y plus 3x equals 180. And again, we'll fill in 20 for x right here. Okay, so we're going to get 3y plus 3 times 20 equals 180. And we're going to end up here getting 3y plus 3 times 20 is 60 equals 180. Right. You're going to subtract 60. Again, just solve the equation right here. Subtract 60. And we're going to get 3y equals 120. Divide by 3. Divide by 3. Y equals 40. Okay, we had our x equal 20 right there. Okay, and that basically is going to find you all of your different values right here. And again, you can go in and check everything. If you put everything back up here, 3 times your y, which is 40, is 120, plus 3 times 20, 60. 120 plus 60 equals 180. Okay, if you go back to 2 times y, 2 times 40 is 80, plus 5 times 20, 100, 80 plus 100 gives you 180. So that's a nice thing about, when we incorporate algebra. Anytime we're doing any type of equation, we go back and check our work. Okay, so a problem that's a little bit involved, but it used something you just hadn't seen in a while. I think if you saw this, you see this example now. And again, use your notes, look at different examples, work back and forth as you're doing a lot of these problems. Okay, and that's it. That's 10.3 inscribed angles. And again, keep up with everything every day. Make sure you're showing your work, and we'll be good to go. Definitely ask me any questions you have. You can email me with any questions, and hopefully we'll be able to take care of things.